Hello, I'm Giorgio Maluza. In the previous video, we talked about how electrical problems arise and how often just because something works, it doesn't mean that everything is going well. Today, I want to get into the details of the main causes so you'll understand why many systems start to have problems even before showing an obvious fault. The first fundamental point is the wiring. It's the backbone of the system, and if it's not sized correctly or if there is oxidation and loose connections, it can cause continuous malfunctions. So I'll give you a real-life example. On a cruising boat, a refrigerator that consumes 50 watts was connected to a 1.5 square millimeter cable. It worked, of course, but only for a short time. When the refrigerator was left on all night, for example, the cable would overheat and the fuse would blow. After replacing the cable with a more suitable one and checking the voltage drop, everything went back to working perfectly. So it's essential to always calculate the maximum allowable voltage drop and size the cables accordingly. Another very common cause is using batteries that are not suitable for the application. Not all batteries are the same. AGM, Gel, LiFePO4 have different characteristics, and many people think, well, it's new, so it'll be fine. But in reality, you always have to evaluate the actual requirements. Let me give you another concrete example. A customer had installed a brand new LiFePO4 battery in a system that was designed for AGM batteries. The battery would never reach a full charge, the charger was working at its limit, and the inverter was signaling intermittent overvoltages. This is why, and here's the point, it's essential to check the capacity, maximum current, and charging profile of the battery before you replace it. In addition to batteries, problems often arise when the components in the system are not balanced with each other. Adding solar panels, inverters, or regulators without considering the entire system creates imbalances and indirect failures. Let me tell you about a real case. On a boat, two identical inverters were installed in a system designed for just one. And the batteries, of course, were draining too quickly, the fuses were blowing, and the regulator was constantly overloaded. They thought it was the new inverter's fault, but in reality, they hadn't considered that the system wasn't sized for that type of total load. Another factor that causes many problems is neglected maintenance. Even the best system can cause trouble if the terminals are oxidized, the grounds are loose, or the fuses are corroded. I like to give examples, so I'll give you another concrete one. A new boat with perfect batteries and a regulator had problems with flickering lights and voltage drops. After cleaning the terminals, tightening the connections properly, and measuring all the voltages, everything went back to working as expected. In short, before changing anything, it is essential to analyze the system as a whole: wiring, batteries, added components, and maintenance. Only then can you understand what is really causing the problems, avoiding unnecessary interventions, and above all, superfluous expenses. On my website, you can find diagrams, concrete examples, and micro-calculations to understand how to size cables and batteries. And if you want, we can analyze your system together through an online video consultation so we can look at the numbers, measurements, and any concrete solutions.